Hello friends. In the previous lecture, we were discussing about what is the notation of memory, how actually different interfacing components help us to connect the processor to the input-output devices and also to the memory. And we have solved some couple of problems to understand how actually the starting address and ending address of a particular memory is selected, and how the chip is selected, what is the decoding logic, and how do you identify the ending address when starting is given or starting address when the ending address is given. So these are few problems to follow the connection between the processor and the memory. Now in this lecture, we shall discuss how actually the memory read or a write operation is possible between the processor and the memory by using several control signals and also the address bus and data bus along with the interfacing components we have discussed in the previous class. Fine. So, computer organization by the name itself indicates implementation of the architecture. So, as an electronics engineer, you should be well aware how the system is actually connected in the core, like in the practical implementation of the components, basic blocks. So, it is not like a theory, you should know what happens. For example, if it is a general public, they do not bother what is there inside, but we should understand how actually it works because you are the designers of the future world. Therefore, now we shall discuss how actually the read cycle or a write cycle is performed with the help of various control signals which are present from the processor or in the processor, right. So, for the reference of discussion, I am considering 8085 microprocessor. As you already know that 8085 microprocessor is an 8-bit microprocessor having 16 address lines and can handle a memory of 64 kilobytes, provided assuming that the word length of memory is 8 bits or the word length of the processor is also 8 bits. Fine. So, in the last class we have also discussed that word length can be more based on the type of processor. It can be 16-bit, 32-bit and also 64-bit depending on the type of microprocessor and architecture. So, in this example, we shall discuss how actually a word length of 8 bits is brought into processor. What are the different sequence of events which take place in doing the job, right? Fine. Let us consider the processor here. See, this is the processor, microprocessor, and memory. And one interfacing component as discussed in the SDIS class called as latch. Fine. And let us see how actually these data can be analyzed. So, here I am considering the processor 8085. It has got 16 address lines. Okay. So, in the 16 address lines, the lower 8 lines are multiplex lines. I am just considering to the value. So, the lower 8 lines of the processor are connected to memory's 8 lines. Fine. So, remaining lines, for example, say remaining higher 8 lines are the higher byte of address bus. Okay, fine. Okay, so here the lines are AD0 to AD7. The line's lower byte of address bus is AD0 to AD7. Higher 8 lines are A8 to A15. These are the higher 8 lines of the address bus. These are lower 8 lines of the address bus. Between this memory lines, so don't forget that processor 16 address lines are also connected to the memory 16 address lines. So yesterday I gave you one important thing. Memory has separate address bus and also separate data bus in order to communicate with the data. Address bus job is just to select one memory location only. Further story is taken by the data bus and the control signals. So unless until read or write operation is completed, the address should be present on the lines. Then only the particular register is selected. Okay. So now tell me, as discussed in the previous class, if you have followed, now try to understand that the register addresses will start from 0000 to FFFF. For example, say I am taking the last register value, right? And every register has got, memory register has got 8 bits inside it. Okay. Okay. So to bring the data out of that 8 bits, you have got the 8 data lines. Fine. So this is some memory. Starting address of the memory is simply 0000H and ending address of the memory is F. H. Right. So this is the component called as latch. Okay, latch is the component here. So this is latch. Latch. It has got the enable line E, and this enable line is connected to the processor line called as ALE. This is called as address latch enable. Now we'll understand very clearly how actually it happens. And observe carefully that the lower 8 address lines of the processor are called as multiplexed address or data bus. So they can act as address as well as they can also act as data bus provided based on this particular signal. So don't forget that the data lines of memory are connected to the multiplexed address or data bus with respect to the microprocessor. So this is how the actual physical connection is present. So it means that, for example, say here, if you observe carefully, the lines, the higher 8 lines are connected to the higher lines. Okay, an example. Okay. Let me take the same way. So here, if you observe carefully, these higher 8 lines are connected to the, so these lower 8 lines of microprocessor are connected to the data bus of memory. So this is how the actual physical connection of memory is present. Okay, right. So this is the actual connection. These are the data lines of the memory, that is D0 to D7. Fine. Similarly, let us consider some control signals from processor which are connected to the signals, read-write signals of the memory. Assume it is a RAM. Tell me what is the maximum memory that can be handled? Say this is 8085 microprocessor. Okay. So 8085 processor can handle how much memory? How much memory can be connected to it? How much memory can be connected? 8085. So 2 power 16 is equal to 64 KB. That is the maximum memory possible. Now observe carefully. Here the signals for read and write, let us say processor has got a read control signal RD bar. Memory also has got a read signal. I am taking one is read control signal, processors, and other one read signal. Because processor is controlling the operation, memory should just accept the control. Memory is not controlling. Fine. Now next one. Similarly, processor has got write control signal and memory also has got a write signal. So processor has got a write control signal. Memory also has a write signal. And one more is the chip select. So chip select is for decoding logic. Don't worry about that, because from address lines, whichever are left, that will be taken for decoding logic. So here, tell me total how many address lines are there? 16 lines of processor are connected with the 16 lines of memory. So there is no line which is left for decoding logic. Generally, what in the they do in the practical scenario is whenever the lines are not free, this chip select will be simply grounded. So this is what we are calling it as chip select of the memory. That is a physical connection, right? Now, there is one more important line called as IO/M bar. This line is called as IO/M bar. It is a type of status signal which is indicating memory or IO operation. Depending on the type of the operation, this signal is generated by the microprocessor, because for every instruction what to do is already predefined. If it is communicating with the memory, then it will be 0. If it is communicating with the input output device, this signal will be 1. So, this signal is called as IO/M bar. Now, you will understand very clearly what actually how the lines called as AD0 to AD7 are behaving. For example, I am considering here the lines called as A15, A8, AD0 to AD7. Now, we will come to know what actually happens when the read operation is performed or a write operation is performed. Now, observe carefully. Let me just move diagram so that you can understand easily. Okay, fine. Here, the thing is that these two signals like IO/M bar and the read signal, these two are connected through an OR gate and this is actually given to the read signal of memory, and this signal, combined signal, is called as MEMR bar, memory read control signal. Similarly, the write signal and IO/M bar, these two are also connected. Let me just show you so that you can understand easily. So, here and this write signal, these two are also connected through some OR gate and through some OR gate, and this is given to the write signal of memory, and this combined signal is called as memory write control signal. Fine. What is the need, we will see later on. Fine. So, this is how you can understand. Let us now consider. Okay. Okay, let it be. Now, let us take how actually this can be done. Fine. So, this is the physical connection. Now, there is one important interfacing component called as tri-state buffer. Let me consider some address in the memory. Say some address location is there. There are many locations in which there is one address location. Okay. Say the address is some 6040H, and you know that every register has got 8 flip-flops in memory, standard word length. I am just taking 8 bits only. If the processor is 16-bit, memory may have 16 bits words. I am just taking some data. So, here let the data be something like, say it is 10000111, some data is there. Now, how the processor will bring this data called as, can you tell me the hexadecimal value of this? आप बोल सकते हैं इसका hexadecimal value कितना होगा? 100 कितना हुआ? 8, 0111 कितना हुआ? 7. So 87H is the data in the memory. So let us see how actually the signals are involved to bring this data into microprocessor in a register. For example, some register समझेंगे, वो register का नाम कुछ है. That register name I am just taking as some ये. Okay. Let us see how actually the data is brought into this line is some garbage value, don't worry about it. So, how the data is brought, we shall see now. Okay, and here what is the purpose of one important component? We have studied about one important interfacing component called as tri-state buffer, other one is latch, decoder, encoder. What's the purpose of buffer? Tri-state buffer, not see buffer register is different, tri-state buffer is different. Tri-state buffer is avoiding what? Loading effect, impedance mismatch. Okay, and other one is like it is used for isolation when many devices are used with the common bus. Now observe carefully, this data bus of the microprocessor can be connected with memory, can be connected with the input output device, whatever it is. So when many devices are there, there must be some isolation. Therefore, between the processor data lines and the memory data lines, there is one interfacing component called as tri-state buffer. So we have discussed about it. There are two types of tri-state buffers. One is unidirectional, other one is bidirectional. So that is how we control the flow of data between the devices. So here I am just taking into consideration the tri-state buffer also. So if you observe carefully, so I am taking some block here so that you can understand easily. Okay, so how it can be done, let us see now. Okay, fine. So let us consider one important block, that is tri-state buffer. So there is one more block called as tri-state buffer. Let us say, now tell me, what is the direction of data bus? Unidirectional or bidirectional? Bidirectional. So here this is tri-state buffer. It's a bidirectional tri-state buffer. I am just naming with the IC number. It is bidirectional buffer or tri-state buffer, bidirectional tri-state buffer. So its number is 74LS, its name is 74LS245, I have just named it. So here it's a bidirectional, data can flow from memory to processor or processor to memory. So don't forget that this is the bidirectional bus. So here I am just writing so that you can understand easily. So data can flow on either direction. So here also it's bidirectional. It's bidirectional, okay? Bidirectional. Very simple. Let me draw like this. Right. So data can flow on either sides. So here this will also have one control like enable line. So I am just naming it as bubble 1. So this control is connected to the signals. So I am naming this line as enable line E bar. Okay, fine. E bar. Or if you are not able to look at this, I am just writing here. So this is actually E bar. E bar. Okay. So this is the actual line. Okay, fine. Okay. This is the diagram. Now let us discuss with the help of signals what actually happens. This signal is called as IO/M bar. So it is one status line which indicates what kind of operation is performed. 0 indicates that it is performing some memory operation. The same way 1 indicates that it is performing some input output operation. Now let us discuss how actually data will be brought. First one, always understand, when the address is placed on the bus, a particular location is selected. After that, the concept of control signals comes into picture. Before the address is placed, there is no question of any control line read or write. So it's not required. After selection only it is required. Now observe carefully. Let us consider one register inside the microprocessor which may be holding the address of the memory register which you want to read from. Say the register, some register is there, let us not worry what is this register, okay, some register is there, okay, there is some register. So in this register, I am considering the address where you want to read from. The address is some 6040H, okay. So whichever the memory location you want to read from or write into, that address should be first present inside the microprocessor. How this address came into processor, we shall discuss later on. वो बाद में देखेंगे. पहले समझे कि एड्रेस प्रोसेसर के अंदर है, अभी वहां से डेटा पढ़ना है. इसके अंदर कैसा है बाद में पढ़ेंगे. Don't worry about that. And those people who are listening to the English version, don't worry. Sometimes I may just shuffle so that people can understand easily, nothing to worry. You follow the English version, right? So now let us take into consideration that I want to read this data from memory. So first the microprocessor will send the address on the address bus. But what is the signal which is required? ALE. Why? Because we don't have separate data bus. So whenever the ALE signal becomes 1, let us say now the ALE signal is 1. So when ALE is 1, how all lines are acting as address lines. So here this value is called as higher byte of address. It's called as higher byte of address bus, and this is called as lower byte of address bus. Byte means 8 bits, you are just calling it as higher byte and line. So this is lower byte of address bus, lower byte of address bus. Lower byte of address bus. So when ALE is high, all lines are acting as address only. So this one is also acting as address, and this is also acting as address. I think in the last class we have studied. So tell me, 16-bit address is placed on the address bus. The higher byte is placed on these 8 lines. So 60 is placed on this line, 8 lines, and 40 is placed on the lower byte of address bus. Now observe carefully. Whenever ALE is 1, what is latch? Latch is something like a gate. Okay. So gate closes and opens. Okay. Observe carefully. When the latch is enabled, it is simply acting as a transparent latch. Whichever is input, it is simply delivered towards the output. So what happens? This 40 will be transferred through the latch and applied to the memory. So that is how the 40 has been transferred to memory. Now observe carefully. Whenever a 16-bit address is placed on the 16 address lines, depending on the decoding logic, in 65,536 addresses, only one register is selected. Very simple. Whenever someone calls to you on your mobile number, you are the only person who is taking up the call in the entire country. There is no other mobile number similar to yours in the entire country or in the world, whatever it is. It means that whenever an address is placed, the decoding logic makes to happen that only one register will be selected. So, based on the decoding logic, this register is selected now. Fine. Once the register is selected, what to do now? You can bring the data from the address location, or you can also send some new data to the location. As of now, I am discussing about the read cycle, what happens for the memory read operation. So now tell me, once the address is selected, the address should be locked till the data is brought. So to bring the data or send the data, microprocessor does not have separate data bus. These 8 lines should be used both as address and also for data. But there is no possibility, so we are taking the help of the component called as latch. So now what happens? When the ALE signal is 1, higher 8 lines have got 40, 60, lower 8 lines has got 40. Higher 8 lines, lower 8 lines. This location is selected. Fine. Now what happens? I want to bring the data. To bring the data, I have to prepare the data bus path. Therefore, so it is 40 only, don't get confused, it's 40, it's not 46. Right. Once the ALE signal becomes 0, then the higher 8 lines will remain as address bus only, no change, but now these are acting as data bus. It means that is what the concept of multiplexing is understood here. So whenever the ALE signal has become 0, it has become 0, the latch is closed. When the latch is closed, it is just acting as a memory element. Whichever the previous value has passed through it, that previous value will be locked to by supplying it to the memory. So it is just locked. Okay. I'm sorry. Fine. So whenever this ALE has become 0, there is no change in higher byte. Means higher 8 lines, it will have 60 only. These are processor is sending this 8 lines value, but now it is acting as data bus. Observe carefully. Whenever the ALE has become low, latch has locked 40, so microprocessor will not hold this 40 anymore. That is the main thing to follow. Processor will not hold this 40. These lines are now connected to the memory data path. So at the same time, this path is also opened. That is what you should follow very clearly now. Now observe carefully. Here, whenever the AL is low, latch has locked and these lines are now connected. Depending on the operation, whether you want to read or write, the processor will decide whether read signal should be generated or write signal should be generated after decoding the instruction based on the control unit decision. Fine. Now, what happened? If you understood properly, I want to read the data. If you want to read the data, at the same time, see this read signal. What is the signal called as MEMR bar? Therefore, the read signal will be activated. Observe carefully. Is this block a memory or input output device? Kya hai ye block? Is it a memory or input output device? Memory. Then this signal will be 1 or 0? 1. The signal is 1. Sorry, 0. Memory means 0. Therefore, this line is 0. So this 0 is applied here and also here. Fine? Right. Which gate is this? OR gate. Now observe carefully. When read signal is activated, means when read is activated, write will be definitely inactivated. Means both read write cannot happen simultaneously. That's the main thing. Therefore, the write signal is 1 here. Now observe carefully. What is the output of OR gate here? OR gate is very simple, just as addition type. So what's the output of OR gate? So if you know the truth table of OR gate, let us say truth table of OR gate, I am just considering so that you can understand easily. So OR gate, A, B, 0, 0, 0, 1, 1, 0 and 1, 1. If input is 0, 0, output is 0, output will be high if one of the input is high. It means that the output of OR gate will be 0 only when both inputs are 0. Therefore, now observe this diagram. For the first OR gate, the output is high. Therefore, this is inactivated, means write signal is inactive. When these two are 0, 0, this is active and the read signal is provided. And hence, what happens is the read signal is activated. So there is some location selected, and when read is given to the memory from processor, this data is placed out of the memory chip onto the data bus. Okay, then this data is brought into the microprocessor through this component. Okay, now observe carefully. This enable line will be linked up with the read signal MEMR bar, or in other words, that is IO and this signal. So this signal can be given to through some AND gate, and this can be like memory read signal or memory write signal. So now what happens? If either of them is 0, it will be enabling the buffer. So it will be allowing. To control the direction, there are some more signals for the buffer. I am not discussing here. You should understand that whether the data should flow from memory to processor or processor to memory. The direction is decided by other control signals. Let us not worry about them. Fine. So now what happens is, when the memory read signal is activated, this buffer is also opened. Therefore, memory will release the data. First it is placed on the data bus of memory chip. Then this data is brought into microprocessor. Just for understanding, I am writing like this. So all the 8 bits will be passing through 8 lines. It's not one line. Just for understanding purpose, I am writing. So this data will be passing through the bidirectional buffer. It is brought into microprocessor to the corresponding destination. So what is this data? 87. So 87H is the data present on the accumulator. So this is what we call it as memory read operation. So can you tell me the sequence, what happened now? Tell me, what is the value on this bus now? What's the value on this bus? What's the data on this bus? On these 8 lines, what's the value? 87 is coming. 87H. Initially, these lines were used as address. Now the same lines are used as data. That is what we call it as multiplexed address or data bus. I hope you have understood the memory read operation very clearly. I am just making the data in a precise, very simple way. Very simple. Once this address is placed, first of all, understand the sequence of signals. Whichever the data you want to read from memory, that address will be present in the processor. So initially AL is 1 address is placed, all the lines are acting as address bus. Then depending on the decoding logic of memory, one register is selected. After one register is selected, the data path of microprocessor is not separate. So we are preparing the data path by making ALE 0 with the help of latch. When the latch enable line is 0, latch will supply 40. Therefore, 60 is supplied by microprocessor. So initially it was 60-40. When ALE is 0, it is 60. Now 40 is supplied by the latch to the memory, and hence there is no change in the address. Therefore, once the ALE has become 0, now you have to bring the data path is ready and you have to bring the data. To bring the data, the control signals from microprocessor is generated. So IO/M bar is equal to 0 for memory operation, read is also activated, and hence this OR gate will become 0. It is activating the read signal. When read is activated, the data is first retrieved from the memory onto the data bus of the memory chip. Then it is brought into the microprocessor into some register based on the instruction. So here you should understand that the responsibility of latch is to hold the lower byte of address till read or write operation is completed. Similarly, tri-state buffer is just used here for providing isolation between these 8 lines and other or processor and other different types of devices. That's the purpose of buffer. I hope you have understood how these 8 lines can be used either as address bus or data bus. So that is what we call it as memory read operation. To bring the next data, let us say you want to read one more location. So this address will be present here inside the processor by incrementing or whatever it is. So again address is placed. So again ALE is 1. The new address will be flowing. It is selected, so on, etc. So here there are few things to be noted. You should know what is the sequence for memory read cycle and what is the time taken by memory to bring the data out of it, and what is the thing to do for avoiding that delay of time. For example, I have asked you a question. In your brain, there is lot of data, enormous of data. I have asked you a question. You have listened to the question through the input device here. It has gone to the brain. Existing data in your brain is compared. You have done some logical calculations, whatever it is. Then the output is delivered by the mouth or in subject you are writing. Followed? Right. So after listening till the output has come, you have consumed some time. That is your memory access time. Some people may have more memory access time, so the response is late. Some people will have very less memory access time, so response is fast. Depending on person to person, memory access time is different. In the same way, memory chips are not designed by the same manufacturer. There are several manufacturers. Based on the company, based on the components they have used and the logic they have designed, memory access time is different. Followed? Right. So based on this, you should understand the responsibility of ALE, the latch, buffer and the control signals. That is how operation is performed. If you have understood, can you analyze for the write operation what to happen? Can you tell me for write operation what happens? Selection of address is same, but when ALE is 1, when ALE is 0, latches held the lower byte of address, data path is ready. Only thing is, instead of read signal, write signal, the write signal will be active, so read is inactive, and this signal is activated, so gates are already open. Whichever data you want to pass, the data will be passed into the memory. That is the sequence for write operation. So MEMR bar is memory read control signal, which is a combination of these two. MEMW is a memory write control signal, which is a combination of these two. So it's very important concept to understand the remaining data whichever is present for the other processor or the CPU design. Now we shall discuss what are the sequence of events which took place in this memory read operation. Right. Sequence for memory read operation. Right. First is you have to select the address. So when ALE is 1, you are selecting the address. Select memory address location. Number 2, after selecting, you have to bring the data, so prepare the data path. So you are using the help of the signal and latch. When AL is 0, then immediately AD0 to AD7 lines are acting as data bus. At the same time, the latch is holding the address. So latch has got the lower byte of address, lower byte of the address. Now, third one, once the data path is ready, we have to use the control signals now. The processor will generate the control signal. You may have a doubt, sir, how does the processor know when read is required or when write is required? That is based on the instruction code. Based on the instruction code, if it has to perform a read operation, then the read signal is activated. So, who takes care of all these things? The control unit which is present inside the processor that manages the whole sequence of events which have to take place. For example, the brain is one of the important control logic for us, for the human body. It has got memory and also the control signals. That is why the entire motor nerves, everything will be handled by the brain only. So that's why when a person meets with some accident, if you get some injury at the head or any place near to the brain, if it is disturbed, then those people will not be much active. Okay, so that is why we must take care of ourselves. Okay, fine. The third one, when read signal is active, what happens here? When read is active means here read is active, IO/M bar is 0, and at the same time write will be inactive, that is 1. So these all together, these two together only we have written as MEMR bar. So when the read signal is activated, so what happened for all these things? So when read signal is 0 means activated. So what happened when the read signal is activated? Number 4, actually it is combined only, just for understanding I am writing like this. When read is activated, the data from memory location is placed onto data bus of memory chip. Data bus of memory chip. Then into, or you can say then on to AD0 to AD7. Then on to AD0 to AD7. So that is simply into the microprocessor. I am not talking about buffer. By the way, it comes through buffer only. Don't worry about it. So this is how actually the read sequence will be performed. So if it is write sequence, in the objective questions, they will give you what is the correct sequence of memory read operation, or what is the correct sequence of IO read operation, so on, etc. So if it is the write operation, these two are same. Instead of read, write is generated. Quite reverse task will be taking place. Fine. This is one important thing to follow. So let the processor be anything, the concept will be same, almost same. Only 1 or 2 signals will be extra in other process. That is about the memory read sequence which is required. Fine. So the other important objective point of questions is there are some definitions which are to understand. You know the purpose of latch here, what is memory access time, so on, etc. will be discussed, right? Now come to the point. You can write the purpose of latch here. In this scenario, what's the purpose of latch? So you can write down what's the purpose of latch. The purpose of latch here. What's the purpose of latch? So what's the purpose of latch here? So it is used to hold the lower byte of address till read or write operation is completed. Write operation is completed. Okay, that's the purpose of latch. The next thing is, what is the meaning of memory access time? Memory access time. What is memory access time? If you observe here in the diagram, it starts from initiation to completion of the job. What is memory access time? It is the time elapsed between the initiation of an operation and the completion of that particular operation. For example, if you are doing the read operation, it starts from the address placed on the bus, okay, read signal given, and how much time the memory will take to release the data onto the bus. Till this part of time, it's called as memory access time. So there are two different types of definitions for this, so that you can understand in any scenario. One is memory access time. It indicates the time elapsed between initiation of an operation and completion of that particular operation. Or in other words, in this diagram, if you observe, that you can say the time delay, or the time delay between address placed, the time delay between address placed on the address bus and data retrieved or accessed onto data bus of memory chip. So that is what we call it as memory access time. So this time is approximately in terms of nanoseconds. Okay, that will be in terms of nanoseconds. That is what we call it as memory access time. So you can analyze now. Tell me, do you require memory access time to be more or less? Logical thinking, very, very less. If memory access time is less, then what happens? Speed will increase for the total overall operation. If memory access time is more, then definitely system is slow. That is how we should understand the data. Fine. What is that is called as memory access time. So this memory access time depends on memory device. It's not based on microprocessor. Okay. So next one is memory cycle time. What is memory cycle time? So memory cycle time is the time delay between the initiation of two consecutive operations. For example, if you are performing two consecutive read operations, initiation of first read till the initiation of second read, that is what we call it as memory cycle time. Okay, writing here. Memory cycle time. The time between initiation of two consecutive operations, like between two read operations. Okay, from the first read till the starting of next read. So that is how we can call it as memory cycle time. So that is about the latch, memory access time and memory cycle time. So observe carefully here that the processor is a high speed device. The microprocessor is high speed device. it works very fastly. But the IO device and memory are low speed devices. So even though the processor is high, if memory is not responding, there is no use. That is why people thought how to avoid this delay of time. So processor will be idle unless the memory responds. So to avoid such problems, people thought that if memory is outside, then only there is a problem. Let us say if memory is present inside the processor only, this memory access time is not required. Processor within itself only it can manage. It is very high speed. Then they introduce some type of memory is called as cache memory. So this memory access time, the memory access time can be reduced by number one, introducing the cache memory which contains the frequently used data and instructions. Number two, by increasing the memory modules parallelly. Increasing memory modules so that parallel accessing is possible. So we shall discuss about this cache memory and all later on. So what is the meaning of second statement? It means 8085 is 8-bit microprocessor. Let us say you want to perform 2 consecutive read operations. Then T1, T1 for first read, T2 again for the second read. Instead of that, if you can put, let us say 8085 is 8-bit processor, no problem. If it is 16-bit microprocessor, then accessing 2 consecutive locations in the same memory becomes a problem. Let me tell you like this. For example, say one memory chip is there. Let us consider that this is memory chip 1. So assume that the microprocessor is 16-bit microprocessor, 16-bit. Say for example it is 8086 microprocessor. So 8086 microprocessor is a 16-bit microprocessor. What is the meaning of 16-bit processor? The data bus in this case is 16 bits. That's the meaning. Now observe here. For example, this is memory chip 1. I want to access first byte here and the other byte here. 2 bytes I want to access. It is a 16-bit processor. So if I am using only one memory chip which can hold 8 bits, what happens? I have to access the memory 2 times to T1 plus T2, 2 into T1, right? Instead of that, what we do is that whenever the word length is more, like 16-bit, 32-bit, 64-bit, what happens is every chip will hold 8 bits only. We'll use several such type of chips. That is what we can reduce. That is how we can reduce the accessing time. So what happens now is instead of using, let us say, instead of using this one memory chip, we will use 2 chips now. How it is possible? Say here, depending on the interfacing, some odd address, even address can be used. So this is memory chip 1, this is memory chip 2. This contains 1 byte of data, this also contains 1 byte of data. Now, if I am working with some 16-bit type of microprocessor, I should be capable of bringing the data at a time. So, only T1 time is required because I am bringing at a time. That is how we are dividing the words into some modules, module of memory chips. Therefore, what happens here? This has also got 8 lines, this has also got 8 lines. So, now what happened? Very simple. So, from here, 1 byte has come, from here 1 byte has come, but what happens is time is only 1, not 2. It's not 2 T1, it's only 1 T1. So this is also addressed, this is also addressed at a time. So both of them are addressed at the same time, at a time. So address is placed at a time, and both of them are activated with the read signals at a time. Both of them will release. Then these 2 bytes, whatever are there, these 2 bytes are brought into microprocessor. So total word length has become 16 bits. That is how we can make the access time to be reduced. So in all the modern computers, this is the general approach which is present for the memory. Now if you have followed, tell me, if it is 32-bit microprocessor, how do you design? If it is, for example, say if it is 32-bit microprocessor, what is the scenario? Tell me. We followed for a 32-bit processor, how will the memory will be present? What is the word length for 32-bit processor? Word length is 32 bits only. So word length means how many bits can be stored or retrieved in one memory access. That is called as word length. Word length means how many bits of information stored or retrieved or accessed from the in one memory access. That's called as word length. Or with respect to microprocessor, you can tell how many bits it can parallelly process at a time. Fine. That is word length. So 32 bits means how many bytes it is? 4 bytes. So yesterday in the previous class, we have discussed little endian, big endian technique and all. Okay. So generally memory is considered to be byte addressable. Means the memory successive address are used for bytes, successive bytes in the memory word. That's the meaning. So here it is 32 means 4 bytes. Word length is 4 bytes. So 4 bytes means how many memory chips are present? 4 memory chips will be present. So instead of using one memory chip, you are using 4 memory chips. So the first byte will be, so if you observe carefully, yesterday I told you that little endian and big endian. Here it is 8 bit, 8 bit, 8 bit. So this is 32 bits. This is 8 bits. This is also 8 bits. This is also 8 bits. And this is also 8 bits. Now first what happens here, it is 1 byte, 1 byte, 1 byte and 1 byte. So let us say it is 0, 1, 2, 3. Byte addresses are 0, 1, 2, 3. Based on that, interfacing will be performed. So all of them will release 8 bits each. 8 bits each. So the total value of this one has become 32 bits. So that is how we are improving the speed by dividing the memory into some modules. That is one by which access time can be reduced. The other one is by using the cache memory. What is cache memory? Cache memory is something like it can be inside the processor or outside, whatever it is, but that will hold the frequently used instructions or data so that the processor need not go to the memory outside like main memory, RAM, ROM, whatever it is. Like this, we are improving the speed of microprocessor by using cache. And there are many optimization techniques for reducing the time delay inside the cache. We shall discuss the concept of cache in the further classes. I hope you have understood what actually is the meaning of memory access time. Till now, we have discussed about how the read operation is performed and what is the advantage of using the cache memory in a simple way, and also if you divide the memory modules for each byte, then how the speed can be improved. Fine. You have to see that the time is as much as less possible to make the user applications to be very fast, because generally when a computer is designed, that is based on the current trend or current scenario. What the user requires, the designer should understand that. Then only the output product will have a very good market value. So that is how the memory access time can be reduced in the design of system. Now we shall go for the internal architecture of a CPU. As per the syllabus, if you have remembered the syllabus for GATE 2021 for ECE. So what is the syllabus? One is machine instructions and addressing modes. Next one is arithmetic and logic unit. Next is data path and control unit, and the next one is instruction pipelining. By the way, memory is already understood. Memory topic is also there. You should know some basics of memory, and you will be studying about the memory in digital electronics also. Right. So this is the syllabus. If you observe carefully, in all these parts of the syllabus, the main orientation is to understand the design of the microprocessor. Remaining blocks are only helpful to it to solve the job. So data is collected from the input device, sent to the output device, remaining always same. Memory plays very important role, and with respect to the processor, it is utilized. So without the memory, you cannot handle the processor. So therefore, here machine instructions are meant for processor only. Addressing modes will give you how the data is approached for a particular instruction, and arithmetic and logic unit is also part of the processor. And similarly, the data path and control, how the control unit initiates the signal to perform certain tasks, that is also inside the processor. Similarly, instruction pipelining, so whenever the program is present in the memory, how to perform the parallel execution so that delay can be reduced and speed can be improved, means the overall reduction of time in the average execution time of instruction. So the last one is memory. Already you know it, that how important memory is for handling the data. So the most important thing in the computer system is the CPU. So you should understand the logic of CPU on a high basis as compared to the others. So let us now discuss the architecture of the processor, internal architecture. So any type of processor has got internal architecture of microprocessor. Okay. So what is this internal architecture? So this internal architecture of the processor can be broadly divided into certain functional units. So what are these functional units? Any kind of processor will have some registers. It's called as register unit. The next one is arithmetic and logic unit, and the third one is control unit. And this control unit can be further divided into signals which are especially for generating the time. So timing and control unit. Okay. The next one is interrupt control unit. The next one is IO control unit. Sometimes we call it a serial IO control unit. IO control unit. So it can be for serial data also. So in other words, we can also call it as IO control unit, or you can also say this as serial IO control unit. So that is how the total internal structure of a particular microprocessor will be designed. So the important role is played by all these blocks, but the initiation of timing signals which are meant for doing the actions is generated by the control unit. And the data is brought from memory into the registers. They are operated inside the arithmetic and logical unit for addition, subtraction, so on, etc. And the resultant value is dumped to the IO devices. So the sequencing of events is the most important thing in the design. How to solve the data, how to move the data with the help of a particular instruction. For a particular instruction, what to perform is decided by the control unit only. So these registers are different for different types of microprocessor. So I am just giving you some basic registers which are present inside the processor and how they are actually connected to the memory. Connection between processor and memory. Okay, fine. So if you consider this, how actually they are present, let us discuss now. Okay, so here is memory. Here it is memory, and processor is also present here. How it is present, let us see. This is the internal structure of the processor. Okay, inside the processor there are several blocks. Again, say there are some registers. What to do with this, I'll tell you one by one. Fine. So how they are connected, let me just tell you. So this is memory, and there are few registers which are present. What are the names of registers? Let us see how the connection is present among them. Okay. That is how is the connection between them. Okay. It is some right. There are few registers which are present inside. Let us see what are the names of these registers. This is called as memory address register, memory data register or buffer register. This is the control unit, and this is arithmetic and logic unit. And there are some important registers called as PC, instruction register, and several other registers like stack pointer, so on, etc. So let us see how actually it is performed. Fine. So there are different types of registers here. For example, depending on the microprocessor, depending on the processor, these registers may vary. Okay, so these registers are called as general purpose registers. I am just naming them as say R0, so on, etc. There is some R0, R1, so on, etc. This is Rn-1 register. Is it clear? So these registers are all generally called as general purpose registers. Okay, they are used for general purpose. So inside the processor, we have got register unit, control unit, and some arithmetic and logic. So this is register unit, control unit, and ALU. So based on the processor, they change. For example, this is called as memory address register. What is the purpose of this register? So this register, among all these things, you should understand there are two buses. One is the what you call address bus, other one is the data bus. So among these registers, this register length means whatever the length of this register is, this register length is based on the address lines, based on the address lines. Okay, so how it is present, let us see. So this is actually based on the address lines, based on address lines of processor. Okay, if microprocessor has got 16 address lines, memory address register is also 16 bit length. What is MAR? It contains the address which has to be placed on the address bus for either read or write operation. So whichever the address you want to read from or send to, that particular address is present in the MAR. So it is used to hold address of memory or the IO device before it is placed on the address bus. Similarly, memory data register is based on the data lines. For example, if you consider this memory data register, or sometimes this MDR is also called as MBR. This is called as memory data or buffer register. Memory data or buffer register. What is the purpose of this one? It is used to hold the data before it is sent to the memory or when it is accessed from the memory. So this MAR and MDR are not user accessible, means a programmer cannot access them. That is default inside the microprocessor. So this MDR depends on, this MDR is based on the data bus. So this is just based, this MDR is based on the data bus. That is what you should understand. Based on the data bus, or in other words, word length, we can say word length. Is it followed? Right. Similarly, these general purpose registers are also based on the word length only. It means how many address lines are there, based on that the MAR will be present, how many data bits can be accessed parallelly, the word length that is present for the remaining all, whether it is MDR or general purpose registers IR. But program counter also is based on the address lines only. So what is the meaning of this program counter? Whenever some instruction is brought from memory to keep track of a program, the program counter will be present. If the processor has got 16 address lines, program counter is meant for address, so it should also be 16 address lines. So that is about the PC. We shall discuss what is the purpose of each of these registers. This is called as instruction register, which is just used to hold, it is used to hold, it's called as instruction register, used to hold the instruction or opcode of present instruction. This contains address of the next instruction, and general purpose registers names can be different based on the microprocessor. Some processors will have 6, some processors will have 8 depending on the type of microprocessor. So this is the general connection between the processor and memory. And the control unit, as we have already discussed, it will be responsible for initiating the sequence of signals which are meant for the events which have to be performed for read, write, IO write, whatever the operation it is, or fetch. So arithmetic and logic unit, this is responsible for performing the arithmetic and logical operation after the data is brought into such type of general purpose. Why they are called as general purpose? Because each register has got some significance. So these general purpose registers can be used either to hold the data or address depending on the instruction. That is the actual meaning of general purpose register. It means, to conclude, general purpose registers will not always have address, will not always have data. The data in them can be taken as address or data based on the corresponding instruction. Fine. So that is how the operations will be performed. Right. So control unit has got a control over all these things. It is like a brain or important block of the processor. So this is how we are going to study what is the generalized design of computers, and we shall take one into account like 8085 processor later, and we see how actually the operations can be performed. Let us continue the different types of functional units which are present in the processor or CPU. So to understand the computer organization, it is better to follow one simple microprocessor. What are the features of that? Then you can expand to the other discussion. As I previously told you, if you know how to ride a bicycle, definitely you will be able to ride a bike. Only little thing is to know how to operate that accelerator, so on, etc. If you know how to ride one kind of bike, it's not a big task to learn the other bikes. Only thing is the gear mechanism and the braking system, front brake or light system, that's all. The same way, computer also, if you can understand one type of CPU or a microprocessor, it's not a big deal to follow the other type of microprocessors. But this subject, as it deals with the implementation or the design of the internal circuitry, you must be very crystal clear how actually each block is concerned about. So that is why I would like to discuss the topic by considering the basic microprocessor of 8085. Further, I would extend the discussion to generalized design of CPU. That's what I mean to say. So in the previous topic, we have discussed what are the connections between the CPU or microprocessor and the memory. So the registers which are present, as you already know that microprocessor, for example, I am considering the microprocessor, say this is the processor. Okay, fine. So this is the processor. Okay, let it be white. Okay, now look at this. Say this is the processor. What does the microprocessor contain? What does the microprocessor contain in it? So the microprocessor contains arithmetic and logic unit, control unit and registers. Accepted? Fine. So these are the three basic functional units which are present, but here again the internal architecture of the microprocessor can be further divided into 5 parts. So this is 1, 2, 3, but this control unit can be divided into 3 types, that is timing and control unit, timing and control unit. Other one is interrupt control unit, and the third one is the IO control unit, or in other words you can say with respect to 8085, this IO means it is serial IO control unit, that is what you can say. Fine. So these are all 5 functional units that are present in the 8085. So generally any kind of microprocessor or CPU will contain these blocks, but the only thing is the number of registers or the type of arithmetic or logical operations is a bit different. That's the only change you need to understand. Fine. So here if you observe carefully, the registers what we are going to study now, which are inside the microprocessor, are of 2 kinds. One is called as general purpose registers, other one is called as special purpose registers. One is general purpose registers, other one is called as special purpose registers, Now I would like to emphasize the concept of this special purpose registers. What is the need for having this special purpose register in the further topics? First we'll normally discuss what actually is the purpose of these registers, what is the significance of each type of register, how is it useful for bringing the instruction to the processor, how it understands. These all things shall be understood in this discussion. Then we'll go for other functional units. So the registers are of 2 kinds. One is called as general purpose and special purpose register. If you consider that this processor is 8085 microprocessor, now if you remember the things which were discussed in the previous lectures, 8085 is how many bit microprocessor it is? An 8-bit microprocessor. Okay, how many address lines are there? 16 address lines. How much memory can be handled by it? 64 kilobytes of memory. Which type of architecture it follows? Like Harvard and other one is Princeton architecture. It follows the Princeton architecture. What is the meaning of Princeton architecture? Both programs and data are present in the same memory. So these are the basic things you should keep it in a mind to understand the internal structure. Fine. So let us discuss what are the different types of registers, how they are useful in the processor. Right. So inside the processor, there are registers which may differ in the number based on the type of processor. So one is general purpose registers, other one is called as special purpose registers. So in 8085, the total number of general purpose registers which are present are 6. So what is the word length with respect to 8085? How many bit processor is that? 8 bits only. So word length is also 8 bit, right? So there are 6 8-bit registers. There are 6 8-bit general purpose registers in 8085. Okay, so this number can change in other processors. For example, in 8086, these are like 16-bit registers. There are AX, BX, CX and DX. So that is 16-bit means you would have lower byte and higher byte. So that is how you get into the 8086 registers. Therefore, there is no perfect fixed value for these registers based on the which is restricted to a particular microprocessor. There is a different notation for these registers. Some processors will have 6, some may have 8, some may have 32 based on the requirement and the design. Okay, so how many registers should be present in each processor, that is based on the selection of instructions which are required for the microprocessor. So the manufacturer will first decide what are the tasks to be performed. For that task to be performed, what are the registers which are required inside the CPU. So based on the instructions decision, these all registers will be considered, right? For example, at your home, you want to buy some chairs. Will you buy a whole shop of chairs? No. Based on your budget, based on your requirement at the house, how many people are there, what is the population in the house, based on that we'll buy. Same thing. When the manufacturer wants to buy or manufacture some processor, depending on the current scenario in the market, what the user requires, based on the cost, based on the speed, so on, etc., they will decide that. It's not a fixed value. Okay. So 6 8-bit general purpose registers. What is the meaning of this general purpose registers here? So the meaning of general purpose registers is these registers can be used to hold the address or data. It's not and data. Address or data depending on the instruction. Address or data depending on the instruction. That is the meaning of general purpose registers. You will be able to follow this point whichever is discussed when we study about the instructions. Okay, that is general purpose registers. What are these registers? They are B, C, similarly D, E and H, L. So these are the general purpose registers in 8085. As 8085 is 8-bit processor, every register is also 8 bits in length. So when you combine these two registers, then that is called as register pair. That's called as register pair. So if you combine the registers, register pair is of how many bits length now? 16 bits length. So in 8085, there are 3 register pairs B, C, D and HL. Okay. Now general purpose indicates that whether B, C, D, HL, they may be used to hold the data of 8-bit length, or they may also be used to hold the address. Tell me, with respect to 8085, what is the number of address lines? What's address bus length? 16 bits. So when you want to use these register pairs to hold the address, then they will have 16-bit value of address, or you may use this individual registers or as 8-bit data or byte of words. That is the meaning of the general purpose registers. How it is done, we shall discuss in the further lectures. Okay. Come to the next one. So these general purpose registers can have either address or data, but one one register pair like HL pair is called as default memory pointer. Means in this 8085, which is basic microprocessor, one register is by default used as a memory pointer. For example, say that I'm using some instruction. Say the instruction is move some A comma M, or move some B comma M, whatever it is. Let us say I'm writing something, say move B comma M. Always while reading the instruction, this is considered to be the source and this is destination. The meaning is move the content of memory to register B. So here data is present in the memory, but in the previous topic we have discussed how data is brought into microprocessor. It means here M, what is M? M is some memory content whose address is present by default or implicitly in the HL pair. Implicit means by default in the HL pair. It means that, let us consider this as memory. How it actually happens, let me show you. For example, say I have written the instruction called as move B comma M. So this is the processor. Inside the processor, the HL pair register is present. Okay, this register has got some value called as 6090 address. In the memory, there is an address called as 6090, some address. As you already know, starting address of memory is 000H, ending address is FFH. Okay, fine. This is the memory connected. Okay. Now, this is the bus with respect to the memory, whatever it is. Now, what happens is, when the microprocessor decodes this particular instruction, the meaning of instruction is move the content of memory to one register of the processor called as B. So regular processor as usual, let us say 6090 is one memory address. In this there is some data called as some 84H, let us say. Okay. So when the instruction is executed, it will be brought into processor, decoded, and processor understands that wherever M is there, M indicates memory content or memory register whose address is present in the HL pair. So with respect to this instruction, the processor after decoding this will by default understand that the value of HL pair should be placed on the address bus, and whichever is the data, this data is brought into the processor, this data is brought into the processor to the corresponding register called as B. So this is the actual meaning of default register. So with respect to 8085, HL pair is called as default memory pointer. Default memory pointer. Fine. So wherever M is there in 8085, it is by default taken as reference from the HL pair only. That's the meaning of HL pair. So it is given one extra feature, right? Next one, let us go for the other special purpose registers which are present. Okay. Now let me consider the special purpose registers. What are the different types of special purpose registers? So special purpose registers. Fine. There are different types of special purpose registers. One among them, we can say its multi-purpose register is called as accumulator. Okay, fine. It is denoted by ACC. What is the meaning of this accumulator? So this accumulator is also an 8-bit register which contains one of the operands meant for the arithmetic or logical operation, and the result is also stored in the accumulator. It means if you want to perform any addition, subtraction, whatever it is, one byte should be present in the accumulator and the second byte can be in another register or from memory also. Therefore, that is what this accumulator has got some speciality. It means after the operation also result is stored in the accumulator. This is because in order to reduce the total length of instruction which is stored in the memory. So when the processor executes one instruction, instruction should be brought from memory. If the instruction has got more number of bytes, like where is the data address, okay, or where the data should be stored after operation, if you mention everything in instruction, therefore the instruction would occupy more space. That is why, to avoid the wastage of time in accessing the memory, such type of registers have been introduced to the inside the microprocessor. So what happens is this accumulator is also an 8-bit register. Okay, 8-bit register. So how the Intel structure is there, let us see. For example, say this is the accumulator. How it is used, let me just give you one simple example. This is accumulator. Okay, I am denoting as ACC, and there is one more register called as, say, a temporary register. Temporary register, temp register, and say this is some ALU. Okay, how the operation is done, let us see now. This is the arithmetic and logic unit, and the temporary register data would be taken from here, and one more is the accumulator register. Okay, 1 minute, let me just solve like this. Okay, let me just take another way. So this is accumulator, this is some temporary register, and there is one more register to show the status, that is called as flag. Okay, a flag register or flags. This is ALU. Okay. Now, the main important thing to follow is that some registers are given a specific feature inside the processor by default. So in 8085, this accumulator has got number of purposes. Most of the arithmetic and logical operations should be done with respect to accumulator only, so that it is easy to design the CPU internally. Okay. Now, for example, I want to add two registers B and C. I want to add B plus C. So you cannot directly add this B plus C, or you cannot subtract this B minus C. So one byte should be definitely present in the accumulator. So this B should be brought to accumulator, A plus C can be done, or C should be brought to the accumulator, A plus B can be done. individually these two cannot be operated. Fine. So for example, assume that this okay. Let us assume that one byte is already present in the accumulator. Say one byte is present. I want to add 2 bytes. Let us see how it happens. Say there are 2 bytes here. Okay, I am taking 2 bytes. Say B has got some 20H, C has got some 60H. Let us say I want to add B plus C. Both of them cannot be directly operated. One should be present in the accumulator. Say accumulator already has got some 20H. Now I want to add register A, means the content of accumulator. I am denoting the content of accumulator with the brackets, plus I want to add content of C, let us say. So already A has got this data. C, the second data, how it comes, let us see. Second data, the C data will be brought into this temporary register, that is 60 will be brought here based on the instruction. Let us say there is one instruction called as add C. So in add C, by default the value of C will be added to accumulator only. So this is designed in such a way that instruction occupies less memory space. Okay, by default some registers are considered. So what happens is these two will be added here in the arithmetic and logic unit. Now add these two, 20H plus 60H. What is the answer? 0, 80H. So this arithmetic and logical unit, this is where the actual operation takes place. 20 plus 60H will be happening here, and after the operation, this result, whatever the result is obtained, this result is then automatically brought into the accumulator again. Means this result after the operation is brought into the accumulator. It means this was the before operation data and this is the data after operation. So after the operation, what is the value? 80H. It means register contains the flip-flops. The status of flip-flops is changed from 20 to 80. What is the binary pattern of 20H? What is 20? 0010 0000. What's the binary pattern of 80? 80 means 1000 It means before the operation, this was the status of the accumulator flip-flops. And tell me how many flip-flops changed. So this flip-flop changed from 0 to 1 and this flip-flop changed from 1 to 0. So it means that the result has been overwritten into accumulator. मैंने operation के पहले क्या data था, operation के बाद क्या data था. That's what you should understand. मतलब this register में data जो था, it has been overwritten by the result. That is how we can understand how the data is manipulated. And based on the result, is the result 0 or is the result having some overflow or some carries out of the 8 bits, whatever is there, the status of result will be given by this particular register. So the status of result is given by this flag register. Sometimes they are called as condition code flags or condition code flip-flops. It is also called as status register. We shall discuss one by one how they are used. And this is one temporary register to hold one of the bytes when some operation is being performed. That is how some internal logic circuitry is there to perform the task based on the instruction which is present. So in 8085, the accumulator plays very important role in performing the operations. Fine, that's about the accumulator register. Now let's go for the next one. So this is where the actual arithmetic and logical operations are performed. Fine, let us discuss the next one. The next register name is program counter. One of the most important registers for execution of the instruction. This program counter is denoted by PC. So this program counter value, if you take as generalized form for any kind of microprocessor, whatever is the address length of microprocessor, program counter will also be of same length. In 8085, this program counter is of 16 bits length because 8085 is 16-bit microprocessor. So program counter is also 16-bit length. So what is this program counter? the program counter is a 16-bit register with respect to 8085, which will always contain the address of the next instruction to be fetched and executed, or we simply say it contains the address of next instruction to be executed, or we can also say that it takes care of program sequence of execution, who is monitoring the execution of each instruction one by one. It is a program manager. It is automatically incremented by 1 for an operation depending on the instruction. What is the meaning of this? So, you can say that program counter is a register inside the processor, special purpose register inside the processor, which always contains the address of next instruction to be executed. It is incremented by 1 for an operation depending on the instruction, that is automatically incremented or implicitly incremented. Okay, so this is how each special purpose register has got separate significance. How to understand this program counter? Let us see now. So, if the processor has got some 24 address lines, program counter will also be 24 address lines. If processor has got 16 address lines, it is 16 address lines. That's the meaning. Okay, let us consider how actually this program counter can be understood. Say this is the processor, this is the processor, and you have got memory here. Okay, memory, and the memory is connected to the processor. Okay, so memory is connected to the processor, and in the memory there are some instructions. Let us say instructions are present inside the memory. Say this is the code of some instruction 1, this is the code of instruction 2. So this is instruction 1. Like some opcode. Opcode means operation code of instruction 1, and this is operation code of instruction 2. There are 2 instructions. This is some binary pattern, some value. Okay, let us say this is first instruction, this one is second instruction. How actually the instruction executes, now will come to an understanding. Inside the processor, program counter is one 16-bit register which contains the address of the next instruction to be executed. Let us say this instruction is present at some address 4070 and the next instruction is at 4071. Fine. This is memory. Now we'll come to know how actually the instruction execution takes place. Fine. Okay. And there are some registers inside the processor like instruction register, and there is one more block called as instruction decoder. Okay, this is instruction decoder and machine cycle encoder. Some block is there, and there are some registers, say A and B. Assume that the accumulator already contains some data. Say it has got some data 30H. And this also has got some data 90H. Okay. So let us consider this data, A having 30 and B having 90. And XX is one instruction. Say this instruction is of, for example, let me consider like this. This XX is actually say actually the opcode of some instruction, say move A comma B. So this is some instruction. This type of instruction is called as assembly language. Writing the instruction in this form, and when this instruction is given to some software called as assembler, this will convert into relevant code. So let us say this is the binary code of this particular instruction present in the memory. Similarly, YY is the code of some other instruction, let us assume. Now you clearly understand how actually the execution of a particular instruction takes place inside the microprocessor. Fine. Assume that the value of program counter always contains the address of the next instruction. Okay. Say due to some previous instructions, the value of A is some 30, value of B is some 90. Let us say the next instruction which has to run is present at 4070. Now what happens? The program counter contains the address of the next instruction to be fetched and executed. So first program counter value will be placed on the bus. So depending on the decoding logic, this particular memory register will be selected. Then whatever is the value present here, that code or instruction code opcode is brought into microprocessor into a register called as instruction register. So once this job is done, the program counter is automatically incremented to a new value, updated to a new value called as, let us say, 4071H, because the next instruction is at this location. Right. Now, this is what we call it as, in the first class, we have already discussed what are the basic operations of processor: opcode, fetch, read, write, so on, etc. So bringing the opcode from memory to processor is known as opcode fetch. This is what we are calling it as opcode fetch. Okay, fine. Once it is brought into instruction register, this value will be further taken into a block called as instruction decoder. How it decodes and all we shall see later. So this instruction register is also an 8-bit register which contains the opcode of present instruction which is being executed. Right. So this code will be decoded here with the help of a program called as microprogram. Then the processor understands what to perform for a certain code. So for this particular code, after decoding, it understands that the value of B register should be copied to A. So immediately this value of B will be copied to A. So what is the value of A now? A new value called as 90H. What happened to 30H? It has been overwritten by this value, and the content of B will not be changed. It will remain unchanged. That is the main thing in the data transfer operations. So this is how one instruction is executed. Therefore, after completion of this, again program counter value is placed on the bus, one more instruction is brought, it is decoded, and it will do some other job. Like this, the processor job is always to go to memory, fetch the instruction, decode and execute. With this particular instruction, execution means simply copying the content of B to A. So this is what we call it as execution with this particular instruction. So from this scenario, you can understand that program counter contains the address of next instruction to be executed. So what are the phases which were involved in the execution of instruction? So in the execution of instruction, what are the basic steps of execution for an instruction? These steps sometimes are called as phases, both are same. What are the different phases involved? In the books you'll find phases. Okay, so what are the basic steps of execution? Tell me, for any instruction, what is the first step? Instruction should be brought into processor, that is called as opcode fetch. Once the opcode is brought, the opcode should be decoded, that is decode. And the third one is execute. I hope you have understood. So first is fetch, then it is decoded, then it is executed. So this is not same for all instructions, that is different for various instructions. In between, after decoding and between decode and execute, sometimes there may be a chance that data may be in the memory also. Here the data was inside the processor. Sometimes data will be in the memory. So you have to go to memory and bring the data sometimes. So sometimes there may be one more intermediate step which can be called as a read effective address. Say there is one more intermediate step called as read effective address. So it may point to a new address location in the memory. So that is what we are calling it as read effective address. Here there is no question of effective address because register is inside only, that itself is effective address for it. Sometimes it may go to memory and bring the data. So that is read effective address. So these are said to be basic steps of execution. So you should know that these are some basic steps of execution. So very important with respect to the what do you call exam point of view. So there are different type of questions which are possible in this particular point. So program counter plays very important role. Okay, program counter. Okay, so this program counter is one of the important registers to understand. So I'm just pointing out by some stars so that you can understand importance of the subject, right? So that is about the program counter. So don't worry, don't forget about the program counter contains always address of the next instruction. So for any instruction, processor should undergo these basic steps. Okay, now you tell me, answer my question. What do you mean by execution? Till decoding, the sequence of steps are same for all instructions. Execution can be possible inside the processor, or execution can be with respect to memory like read or write operation. Execution can be with respect to input output device also. So the word execution is not an ordinary one. It may mean any kind of operation within the processor from or to memory, from or to input output devices. So these are said to be basic operations of processor. So you can write a note. After decoding the opcode inside the processor, whatever is performed is known as execution. It may be within the processor or with respect to memory or input output devices. That is a point to be noted. What is the other register? Instruction register. Now let me tell you one point here. So this is 8085 processor, so that is why the address lines are 16, so program counter is 16-bit. Some processor may be having some address lines of 24, then program counter will be 24 bits, some k bits depending on the address lines. If a processor is of 32-bit length, then the IR will also be 32-bit length, instruction register. So depending on the word length, the general purpose registers and IR will be present. Depending on the address lines, program counter and some other registers which are used to point the memory will be present. So this is the point to be noted by you people to understand the logic of design. Fine. So you can yourself tell me the answer now. What does IR contain? What is IR having? Instruction register. It is containing how many bits? It is containing which one? The code of instruction. So it can be said as it is an 8-bit register with respect to 8085 which contains the opcode of present instruction. Opcode means operation code, some operation to be performed. Okay, right. So that is what we say as instruction register contains opcode of present instruction. Is it clear? So let us say if the instruction length, can you tell me what's the length of this instruction here? How many bits? What is the length of opcode here? Opcode is how many bits? Every register contains how many bits? 8 bits. 8085 is 8-bit processor or 16-bit processor? 8 bits. So each memory location contains 8 bits. Therefore, here the instruction code is also 8 bits. That is the point to be noted. Fine. So it contains the opcode of present instruction being executed. That's about the PC and instruction register. The next one is, before going to the other special purpose register, there is one block called as instruction decoder. So what happens here? Let us consider now. So you can write the next one called as instruction decoder and machine cycle encoder. Instruction decoder and instruction decoder and machine cycle encoder. What is the purpose of this block? So this is the place where actually the instruction will be decoded. So any kind of instruction will be decoded in this particular block. Clear? So how it is decoded? With the help of a program called as microprogram. There will be some decoding logic circuit inside the control unit. See, the microprocessor contains ALU, control unit and some registers. In the control unit also there are some decoding logics, hardware implemented. So because of that program called as microprogram, instruction will be interpreted by the microprocessor. देखिए, हर एक प्रोसेसर का instructions fixed होते हैं, मैन्युफैक्चर फिक्स करके रखता है, वो प्रोसेसर वही इंस्ट्रक्शन से एग्जीक्यूट कर सकते हैं. एक एक इंस्ट्रक्शन का कोड में जो कुछ भी काम करना है पहले से बना हुआ है प्रोसेसर के अंदर, बस कोड को कंपेयर करेगा, काम करेगा, that's all. It means that every processor has got a fixed design of instruction set, means number of instructions. It can understand only those codes. It cannot understand other codes whichever are present. Is it clear? So there is some built-in program inside the microprocessor control unit such that it may interpret whatever is the code written by the programmer made for it. That is how actually decoding will be taking place. So what is this instruction decoder and machine cycle encoder? So it contains this, this is decoding the particular instruction opcode. Okay, how it decodes with the help of microprogram. You can write the opcode is decoded in this block. So in this block what happens is opcode is decoded. Okay, how it is decoded? With the help of microprogram. With the help of microprogram. What is this microprogram? So what is this microprogram? Okay, what is this microprogram? Microprogram. So microprogram is actually a program. This is written by the chip designer, means manufacturer. Program written by chip designer to make the processor understand what an instruction is. What an instruction is, or it makes the processor to follow what to do for a particular instruction. So this microprogram is actually present in the control unit. Okay, control unit. So it will be decoding in the CPU only. Control unit is a block. So it contains the set of hardware type of instructions which are implemented in the CPU design. So every processor can run only fixed number of instructions. So that is how decoding will be done, and it does the job. So what is the meaning of decoding here? Let us see now. Fine. What's the meaning of decoding? So inside the processor, for example, manufacturer is there. Let us say chip designer means manufacturer. So understand carefully, you'll know what is the design perspective here. Every chip designer will first fix some number of instructions. So fixed number of instructions. So every designer will first fix number of instructions for microprocessor. Based on the current trend and requirement, it will fix number of instructions, some X number of instructions. So what to do for every instruction is also defined. For example, say opcode, some binary pattern, and what is the operation corresponding to it. There will be some opcode XX, some YY, ZZ, some kind of binary pattern, whatever it is. Okay, there will be some kind of binary pattern. So for every pattern, what to do is already predefined. For example, say this is the instruction, move A comma B is the instruction. This is the instruction, let us assume. Okay, so this instruction, whenever it is given to the assembler, assembler is one such type of software which will convert into relevant code. Okay, so what is the meaning of this code? The meaning of the code is the value of register B should be copied to A. This is the meaning of this code. Similarly, let us say there is one more instruction, say move B comma A. Now tell me, are these two same or different? This is different. The meaning is move A to B. So this will also have some sort of code. Let us say its code is some YY, some binary pattern. Okay. So this meaning is move the content of A to B. This is different and this is different. So every opcode or binary pattern of code will have only unique operation. This code will never repeat again in the n number of codes of instructions. So what is decoding now? What is decoding? Very simple. Now whatever the instruction register has got inside it, this value will be compared with the existing codes inside the microprogram. Whichever it matches will just do the job. That's all. Are you able to follow? Decoding means comparing the code of the IR with the existing codes of codes inside the microprogram of CPU. So whichever it matches, it will just do the job. That is the meaning of decoding. Who will take care of all these things? Control unit will be handling all these tasks. Okay, that is how one instruction will be decoded. And we don't bother how the code is generated. That is out of syllabus for us. Okay, how this code is generated, we need not understand that. This is the meaning of instruction decoding. See, very simple. Let us say you are able to understand the class or lecture. What does it mean? You should definitely know the English language. अगर मैं आपको हिंदी में समझाऊंगा तो some people जिसको हिंदी नहीं जानते, नहीं मालूम है, वो लोग को समझ में नहीं आएगा. मतलब हिंदी समझने का जो एक एक वर्ड आपके ब्रेन में है, जब आप कान से सुन रहे हैं, उसको डीकोड करके ही समझ पा रहे हैं. मतलब आपका जो लैंग्वेज है वो ऑलरेडी ब्रेन में फिक्स हुआ है. अगर मैं कोई स्पेनिश या फ्रेंच बोलने से आप समझ नहीं पाओगे. क्यों? उसका डेटाबेस ब्रेन में नहीं है. आप कहां से डिकोड करोगे? In the same way, decoding means you should have a database of that language in the brain. Then only you can understand, interpret, compare. That's the meaning of decoding. Are you able to follow? Right. That is how the processor is also designed. Now, observe carefully. These are n number of instructions. Okay. So, every instruction will have unique operation. In 8085, for example, say in 8085, there are altogether 246 instructions. 246 instructions which are out of some basic formats of 74 basic formats. Like, what is the meaning of basic format? See, move some source register to destination register. This is the basic format. Source and destination can be any general purpose register like B, C, D, E, H, L, A, whatever it is. So, when you change it, the code is changed. That's meaning. So, as such, there are 246 instructions. Now, 246 instructions should have how many codes? Definitely, how many codes you should have? 246 codes, opcode should be present. Now, tell me, to represent 246 codes, how many binary bits are required? Understand carefully. 246 is not a power of 2. It is between 128 and 256. To have 128 different codes, 7 bits are required. To have 256 codes, 8 bits are required. Now tell me, to represent these many codes, how many bits are required? 8 bits. That is why the opcode length in 8085 is 8 bits. So now tell me, how the manufacturer decides the length of the opcode or code of the instruction? Based on the total number of instructions. How will it decide total number of instructions? Based on the requirements of the operations. Okay, everything is interlinked. That is how the opcode length has become 8 bits. Now tell me, which is more preferable? Having more length of opcode or less length of opcode? As much as less possible. If the length of opcode is more, then you require more word length, 16-bit, 24, so on, 32, so on, etc. That is how the speed can be compared in the operations. So, I hope you have understood what is the meaning of decoding. So, we will still clearly discuss about that micro program, what are micro instructions, what is CPU, control unit design and all, we shall discuss in the further classes, right. That is meaning of instruction decoder. Fine. Now, let us go further for one more important register called as stack pointer, denoted by SP. There are several questions which are based on the stack pointer. We shall discuss one by one. What is the meaning of this stack pointer? So, this is also one special purpose register in 8085 which is handling or keeping track of the data that is present in the stack memory. To understand this stack pointer, first of all you should know what is the meaning of stack. What do you mean by stack? Fine. Here inside the processor there are different registers like B, C, D, so on, etc. Okay. Okay. Inside the processor there are different registers. Okay. There are different registers inside the processor. Okay, 1 minute. Okay, let us consider that there are different registers inside the processor. Okay. Okay, let it be. Okay, now let me draw this. Okay, so there are different registers. Observe carefully. And this is the memory. The memory. Okay. So the processor is connected with memory. The maximum memory that can be handled with 8085 is 64 KB. Say here this is the first address in the memory, and this is some last address, whatever it is. This is FFFH, and this is 0000H. Okay, fine. Now observe carefully. Memory is connected to the processor. I'm just pointing out. Okay, memory is connected. Let us say. Inside the processor there are several registers, like you have got BC register pair, okay, and you have got some D register pair, you have got some HL register pair, okay, and this is the stack pointer. Okay, this is the stack pointer. Okay, fine. In all these registers, let us say some data is already filled up. Let us say it has got some data 90, 60, it has got some data 70, 40, it has got some data 1020, something like this. Everything is filled up. Okay. Now, observe carefully. When all the registers inside the processor are filled up and I require one extra register which has to be used, but there is no possibility. Number of registers inside the processor is less. To have more number of registers, commercially it is more costly. So I am having less number of registers. So I want to have some extra free register, but there is no possibility. Now at such circumstances, you can store any of this register contents temporarily for some time in the memory. Where to store in the memory? It requires some pointing register. This is called as stack pointer. So what is the meaning of stack? Stack is actually one type of data structure which is simply a list of elements or data, which is generally words or bytes, and it has got one accessing restriction. What is that? The elements can be added or removed only from one side or one end. That one end is called as top of the stack. So the definition of stack resembles something complicated. Let me explain in a simple way. What is stack? Stack is a part of read-write memory to store the temporary data or the value of program counter when subroutines are used. The value of a program counter when subroutines are used. When subroutines are used. So what is the meaning of this subroutine? We shall see later on. Okay. So you simply understand stack is a part of memory. Okay. Used for storing temporary data and program counter value. How it is present? Let us see. What is stack pointer? Now observe carefully. Let us say in the stack is something like a well. It has got one bottom and the data will be slowly pushed into that place of the stack memory. So how it actually happens? Let us see now. For example, the stack pointer is a 16-bit register with respect to 8085, which contains actually the address of data present at top of the stack. What is the meaning of top of the stack? The latest temporary data which was stored in the memory. Fine. So assume that stack pointer is initialized to some address. Say the address is some F009. Okay. In the memory, there is one register called as, there is some register and the address name of this register is F009. So this is what it indicates. For example, stack pointer register contains some address. It indicates that the latest temporary data which was stored in the memory is present at this location. Let us say it has got some 70H. It means due to some requirement, stack pointer was initially initialized here and slowly have stored some temporary data, and the latest temporary data is present at this address. So whichever is the latest temporary data, that is known as data present at top of the stack. It means whatever stack pointer contains, the data corresponding to that address is called as data present at or element present at top of the stack. So this is the bottom, it is the end, top end. Okay, top, this is bottom. So how actually it is used? Let us see now. Let us say I want to store any register pair content temporarily for some time. So there is a principle of stack, like you can store the data into stack one by one in the decreasing order of address. That is common practice which is used in the design of process. Tell me, what is the address before this? What address is this? Okay, 1 minute. What kind of address is that? Yes, what is the address before it? It is F008. What is this address? F007. Fine. Now observe carefully. I want to store the value of DE into stack. For example, if I want to store DE content into stack memory. Okay, fine. So stack pointer keeps the track of stack memory. Okay, it always points to data present at top of the stack memory. If you want to store a new data into the stack, there is one rule called as memory rule, or you can say little endian, big endian we already studied. Generally little endian is followed, both of the techniques are followed. Here we are taking some little endian, means the lower byte address, lower byte is stored at lower address, higher byte is stored at higher address. So observe carefully. I want to store the value of DE into stack memory. So DE contains some data, say 7040H. 7040H. Okay, then I'll change this data. Let us consider, let us change this data. Say this value is some, so that you won't get confused. This data is some 90H, let us say. Okay, it is some 90H. Now I want to store DE content to the stack memory. Now what happens is, first, where you have to store at 9 or 8 or A. Here stack pointer always will be decremented towards the lower addresses while storing the data. Storing the data into stack is called as a push operation. Removing the data from that stack is called as pop operation. So in 8085, the design is that memory contains 8 bits only per one register. So if I want to store 16-bit register, stack pointer will be modified 2 times. That's a strategy. Or some cases, if it is word length is 16 bits, means every location has got 16 bits, then it can be stored only in one time. Based on the design of process, it may change. Now observe carefully. I want to store DE content. How it is stored? First of all, the stack pointer value should be changed from the current value to one address less than the value. So first of all, stack pointer will be decremented by 1. So I am saying this is SP minus 1 address. If this is SP, this is SP minus 1 address. So then the value of higher register is copied to higher address, value of lower register is copied to the lower address. So first sending the data to memory, what is that called as? Which operation is that called as? Memory write operation. So this D content is stored at this location. Again, to store the next byte into the memory, stack pointer gets updated to one more value like F007. Then the value of the E content, so what is the current value of stack pointer? It is SP minus 2 address. So the value of this E content is also stored to the stack memory. So this is also a write operation. So 40 will be stored. Now if you observed, tell me the value of DE is temporarily stored in the stack memory. So from here to here, this entire data is dumped into the stack memory. This is what we call it as stack. So from here to here, this entire memory is called to be the stack memory. So this is what I am saying as stack. Hope you have understood this. Now, what is the data present at top of the stack? So whichever is the current value So whichever is the current value, that particular data is called as data present at top of stack. Data present at top of stack. Means how many times stack pointer got decremented? Twice. Why is it so? Because memory word length is 8 bits. I want to store a 16-bit register. So 2 times it got decremented. So when the data is transferred into the stack memory, that is known as push operation. Therefore, stack point is decremented by 2. When data is accessed from the stack memory, then that is called as pop operation. Now I have a question for you. Tell me, before the operation, what was the level of stack? From 9 to FF. After the storing data into stack memory, what is the current level of stack? 7 to FF. Is it clear? We can fix one particular reference for the bottom for using the stack memory. That is how the stack memory will be changing. Now, for example, if I want to take the data out of the stack memory, which will come out first? Whichever the data was last stored, that only will come out first. Therefore, we say that the technique involved in the stack memory is known as last in first out. The technique involved in the stack memory is known as last in first out. Last in first out. That is what we call it as technique involved in the stack memory. So there are few points to be noted here. Number one, what is stack? Stack is a part of read-write memory to store temporary data or the value of program counter when subroutines are used. What is stack pointer? It is a 16-bit register or n-bit register based on the processor, which always contains the address of the data which was last stored into stack memory, or it contains the address of data present at top of the stack. So this is called as top end, this one is bottom. Bottom is fixed, only data will be put into or removed from top end only. Fine. What is the principle or technique used in the stack? That is called as last in first out. Okay, so these are few points to be noted into the with respect to the stack memory. Very important register. Fine. We will have some questions based on this. I will be giving one simple question. How it is? Let us see. In a microprocessor, stack pointer is 16-bit length. Stack pointer is 16-bit length, having a value as E501H. Okay. If BC pair having 3497 is pushed into stack, consider word length of memory is 8 bits. 8 bits. Okay. What is value in SP and data at top of stack? This is the question. Okay, this is the question. The point to be noted here is in microprocessor or CO questions, question length is too much, 4 lines of question, but logic is very easy. How to solve this question? Very simple. When a question is given with respect to the stack, first you put a value like this. Okay. Always stack pointer will have the address where the latest temporary data was stored. So some E501 is present. Okay, it has got some previous temporary data. So last temporary data, I am just writing it as some WW. Okay, this is some last or previous temporary data. Previous temporary data. Accepted? Right. So what is the current value of SP? Here. What is the address before it? E500. What is the address before it? 500 means before it will 4FFF. This is the memory. Accepted? Now tell me which content you want to store. Stack pointer contains some value E501 and the content of BC is 93497. So here I am taking some register pair. BC is there. So BC register pair has got a value called as 3497. It has got 3497. Always understand, when a new data is pushed into stack, first of all the stack pointer will be decremented by 1. Then it is placed on the bus. Then higher byte of register is moved here. So 34 will be moved here, and again the value of SP is decremented once again and placed on the bus. Then lower byte is copied here. That is 97. So both the answers are here only. This is 97. So what is the current value of SP? That is E4FF. What is the data present at top of the stack? This is what we are calling it as the data present at top of the stack. Whatever data at the top of stack. Whatever is current value of SP, corresponding data is called as top of the stack. It is as simple as that. Okay, fine. So I will give you one more problem. Try to understand. These are very frequently given questions. Hope you understood this question. Let us solve one more question. Given SP as 16-bit, a register of 16-bit contains 8642H, word length of memory is also 16-bit. Okay. Assume that SP refers to an empty stack location. This is the question. If 8642 is pushed into stack what is SP and data at top of stack? That is the question. So now you think and try to answer. They may give anyway, question can be of any kind. What he says? So gate questions will be of such kind. He says SP 16-bit, register is also some 16-bit, and memory word is also 16-bit. So understand carefully. In the previous case, word length was 8 bits. Now here, observe carefully. You may give with respect to any processor. Okay. May give with respect to any processor. Okay, right. So now observe carefully. So here is the value. This is a stack pointer. This is memory. Now observe, what is this word length? How many bits is this? N bits length. What is the word length of memory? He says 16 bits word length. That is the main thing to follow. It is 16 bits word length. Okay. So this is 16 bits word length. Accepted. Now what is the current value of stack pointer? There is some address. What is the current value of SP? What is he has given? Okay, some value of stack pointer. 1 minute. Here the 16-bit register contains this one. SP value is not given. Let us say the value of SP is given to you. Assume SP has got some value. Say SP has got some value. It is some C002. Let us say some SP has got some value. Let us assume like that. Okay. It means, observe carefully. The question is, he says a register has got 16-bit value. There is some register. We don't know what register is that. There is some register. This register has got 8642. 8642. And he says word length of memory 16-bit. Every location can have 16 bits. Assume that SP refers to an empty stack location. He is saying stack pointer, current value of stack pointer is referring to some empty. What is the value of stack pointer given to you? C002. C002 is the current value of stack pointer. Accepted? This is a different question. What's the next address actually? C003. Now what he says? He says stack pointer is not pointing to the latest memory location or latest temporary data. The new temporary data where you have to store that address is present in the stack memory. That's the meaning of assume that SP refers to an empty stack location, new location. It means the previous temporary data is here now. That is the point to be noted. So here is the previous data. So previous temporary data is present at this location. So the question can be modulated anyway. That's the meaning. So now tell me, if 86462 is pushed into stack, what is the current value of stack? Very simple. He is telling that this memory, this design is such a way that stack pointer points to new empty location. In the previous problem what you have studied, stack pointer always contains the address of data present at top of the stack. That is another question. In this question, he is asking to assume that the new temporary data will be stored at current location of stack pointer only, not at SP-1. So very simple, this data is simply transferred to this particular location, 8642. That's all. What is the value at data? What is the value of stack pointer? Same value. What is the data at top of the stack? 8642. That's all. So the questions can be modified in any way. They can give the question in analysis way. If the question was like word length is 8 bits only, then you should store 2 times. But here word length is 16 bits. 16 bits can be stored in the memory. That is how actually the data can be stored into memory. So there are different types, like it can be word addressable, byte addressable. 1 minute, it is 3 means 2 and 1. It should be, yeah, fine, no problem. He has given like that. Okay. So these are all word addresses. Fine. There are 2 bytes, byte addressable, but he has given like this. Sometimes he also says that the next byte where it is stored. Okay. So this should be actually 4 actually. This should be actually 4 because 2 bytes are there. So 2, 3 will be completed, 4 will be present here. Okay. Actually, it is 4. Let us take it as 4. Okay, 2 bytes each. C002, it is 3, 4, 5, like this it will be stored. Let us assume like this. So that is how the questions can be present. Hope you have understood how to operate the stack memory.